Hey, Wagwan. Yeah, man. Today we'll be looking at a normal distribution question in Module 2 of the Integrated Mathematics syllabus, that is statistics. Now, here the question says if Z is the standard normal random variable, we have to find some probabilities. All right. Now, you should know that when we deal with these types of questions, we will have to use a diagram just so that we can have the understanding of what is going on. All right, so I'm going to just draw a sketch of the diagram here. So let us say that is my z-axis, and I will have a line of symmetry here. Great, that is my line of symmetry. So this is my normal distribution curve. So it's supposed to be very close to the z-axis here. Right, and this is the z-axis here. Great. So you should know that for the normal distribution curve, it is a bell-shaped curve, right? And another characteristic is also that it is asymptotic, meaning that the curve gets very close to the z-axis, but it does not touch the z-axis, all right? And also it is symmetrical. This line here, which is the line x equals 0, is the line of symmetry. And you should know that to the left of the graph, all right, so to the left of 0, that shading there is 50%, all right, that's 50%. And to the right of 0, that shading there is also 50%, okay? Which means that the total area under the curve is 100%, or I can just say it is equal to 1, right? Because 50% is 0.5, so 0.5 plus 0.5 is 1. Okay, let's do the first solution here. So this is part 1, solution. And we want to find the probability when z is less than or equal to 2.09. So I'm just going to draw the diagram so that you can have a visual understanding of what we are calculating here. All right, so that is going to be my z-axis. I'm going to have my line of symmetry, which is the line x equals 0. All right, so this is going to be 0, and this is going to be my graph here. Right, this is just a sketch, right? So we want when the probability of z is less than or equal to 2.09. 2.09 is to the right of 0. So somewhere here is 2.09. That's my z value. And we want less than or equal to. So if we want less than, it means that I will have to shade to the left of this value here. All right. So that area is what I want, right? That probability. Good. So I'm now going to find the probability when z is less than or equal to 2.09 by using the normal distribution table on the formula sheet. Okay? So this is the table that you will get in your formula sheet in the exam. All right, this is the revised 2019 formula sheet table. All right, and if you look carefully, it says if Z is a random variable normally distributed with zero mean and unit variance, meaning that the variance is 1, then phi of Z is going to be equal to the probability of Z less than or equal to small z. So we have to read this table according to the shading. So the probabilities here is going to give us the area under the curve, right? That is to the left of the Z value, okay? And I want 2.09, all right? 2.09 is my Z value here, and I want the area to the left of it, okay, or the probability. So I will have to locate 2.09 here, all right? Let's locate 2.0 in the Z column here, okay? So let me scroll down. Yes, here we have 2.0, right? And if you look at the top here, you have 0, 1 to 9, right? So I want 2.09, 9 is in the last column here, okay? So it means that if I look carefully, here I have 2.0, all right, that's 2.0. And then the 9 is gonna be right here, okay? So this is the value that I want, right here. So my probability is 0.9817. All right, let's write that down. So the probability when Z is less than or equal to 2.09 is going to be equal to 0.9817. And that is my answer. All right, so part 1 is now completed. Let us know the part 2 of the question. This time they want the probability of Z greater than or equal to a given Z value. So part 2, solution. Okay, I want when the probability of Z is greater than or equal to 1.27. All right, so I'm going to also draw the diagram here so that you can see what we need. All right, so let's draw the diagram here. I'm also going to draw another diagram over here. All right, you will see why in a minute. So that is going to be my Z-axis here. And this one here is going to be my Z-axis. Okay, and I'm going to have my line of symmetry. All right, there's going to be my line of symmetry, which is the line x equals 0. Great. This is going to be my curve. Excellent. So I want the probability when Z is greater than or equal to 1.27. 1.27 is going to be to the right of 0. All right. So somewhere here is going to be my value, 1.27, and I want the probability when Z is greater than or equal to 1.27, right? So if I want greater than that value Z, I will have to shade to the right of that value. All right, so I'm going to want all of that area there. Good. So how would we calculate that area? Well, if you look at the table here, right? If you look at the table here that we were using, let's just go back to the shading at the top. This table only gives me the shading to the left of that Z value, right? It doesn't give me the shading to the right. That is the problem. So how am I going to find this area here? Well, here is what we can do. Let us find the area to the left of that z value, meaning that if here is 1.27, let us find the probability or the area under the curve to the left of that z value there. All right, so I'm going to calculate the probability of z, which is going to be less than or equal to 1.27. And if I look at the table here, all right, 1.27, here we have 1.2, right? And 7 is here. So my probability for 1.27 is going to be right here, right? Zero point 0.89. Oh, sorry. I was looking at the wrong one. It's the one here, right? This value here. Yes. So the probability for when z is less than or equal to 1.27 is going to be 0.8980. Okay? So let us write that down here in our working. So the probability to the left of 1.27 is going to be 0.8980. Great. But how does this help us in finding the area to the right of 1.27? Well, if you recall earlier, I had stated that to the left of 0, the area under the curve is 0.5 or 50%, and to the right of 0, the area under the curve is 0.5 or 50%. So it means that the total area under the curve is 50% plus 50%, which is 100%. Okay, so let me write that down here. So I am saying that the total area is going to be 50% plus 50%, which is 100%, right? And 100% is the same as 1. Okay, so the total area under the curve is equal to 1. Good. So I can use that knowledge now in order to find this probability, because I know that to the left of 1.27 is 0.8980, right? And I know that when I add it to the probability that I'm trying to find, that is the probability of z being greater than or equal to 1.27, when I add those probabilities that you see shaded here in the two diagrams, when I add those probabilities, it should be equal to 1, right? Because the area to the left of 1.27, which is 0.8980, plus the probability to the right of 1.27, which is what we're trying to find. When we add those two probabilities, it must be equal to 1. So all I have to do now is to just transpose for the probability that I'm trying to find. So I'm going to subtract both sides of the equation by 0.8980. And if I do that, on the left-hand side, I will have the probability of z greater than or equal to 1.27. And on the right-hand side, I will have 1 minus the 0.8980. Right, 0.8980. Good. And therefore, I can say that my probability is going to be 1 minus 0.8980 is going to give me 0.102. Okay? And that is my answer for this probability here. Great. So it means that part 2 of the question is now completed. Now, part 3 is a bit challenging right? Because we want the Z value, we want the probability between these two Z values, right? So that's going to be a bit of a challenge, but let us calculate it, all right? Now we'll do it step by step. So we now want part 3 solution here. Part 3 solution, and that is when we want the probability of 0.87 less than or equal to Z less than or equal to 2.35. Great. That is what we want. All right. Well, let us also draw a diagram so that we can have a visual representation. All right. So that you can interpret this probability better. So let us draw our normal distribution curve. Okay, so that's going to be my z-axis. I'm going to now have my line of symmetry, x equals 0. Great. That is what I want. Now, remember now that I want the probability that is between these two z values, 0.87 and 2.35. Now, the 0.87 is to the right of 0. So that's going to be somewhere here, right? 0.87 is going to be somewhere there, and 2.35 is going to also be to the right of 0 and to the right of 0.87. So somewhere here is going to be 2.35. Good. And I want the area under the curve between those two z values. So this is the area that I want. All right, that shading there. Good. Now, how am I going to find that probability? All right, how am I going to find that probability? Remember the table here. All right, let me just erase this. Remember the table here. Let's go back to the shading above. It gives me the values to the left of the z value. All right, it gives me to the left of the z value. So it doesn't give me the probability to the right of the z value or between z values. Right, it only gives me the probability to the left of a given z value. Okay, so how am I now going to find this probability? Well, since we know that the table only gives us the probability to the left of a given z value, I can argue that the probability of z less than or equal to 0.87, all right, that is going to be to the left. So this red area that I'm going to shade here, that is the probability that I'm talking about, to the left of 0.87, right? That probability there, plus the probability to the right, right? To the right of 2.35, which is this probability here in the blue, or the area here in the blue, right? To the right of 2.35. So if I add those two probabilities plus the probability that I want, right, which is 0.87, so 0.87 less than or equal to z less than or equal to 2.35, right? That is the area that you're seeing in the green, right? This is the area that you're seeing in the green. That's the one that I'm calculating, which I'm trying to find. When I add all those probabilities, the one in the red plus the one in the blue plus the one in the green, when I add those three probabilities, it must be equal to what? it must be equal to 1, right? Or 100%, because we know that the area under the curve, the total area under the curve is equal to 1. Good. Now, I can find the probability of Z being less than or equal to 0.87, right? By just simply looking at the table, right? Because we know that the table gives us the probabilities to the left of a given Z value. So the probability of Z to the left of 0.87 is going to be equal to what? Just look at our table and find 0.87, all right? So here we have 0.8 and here we have 7, right? So this is the value that we're talking about here, okay? That Z value there, which is 0.8078. That is my probability, okay? So the probability of Z to the left of 0.87 is going to be equal to 0.8078. Great. Now, how am I now going to find the probability of Z being greater than or equal to 2.35? How am I going to find that? Well, we know that if we add, all right, so I'm going to also write a third equation here. So if we add the probability of Z being less than or equal to 2.35, right? So to the left of 2.35, so that is the combination of the red area and the green area, right? So when I add that probability plus the probability of Z being greater than or equal to 2.35, meaning the area to the right of 2.35, that is the area in the blue there, right? So when I add those two probabilities, it should also be equal to 1, right? When I sum those two, it should also be equal to 1 because we know that the total area under the curve is equal to 1. Great. So I can easily find the probability of Z to the left of 2.35 by simply looking at the table. All right, so let's do that. Let me erase this here. And we want 2.35. All right, here we're going to have 5 and 2.3. All right, 2.3 is going to be right here. So I'm going to look at this column here, right? I'm going to look at this column here. So my answer for the probability is going to be that value there, right? Which is 0.9906. Okay, 0.9906. So let me scroll down. So what I'm saying is that the probability, right? The probability of Z to the left of 2.35 is going to be 0.9906 plus, I don't know what this probability is, right? Probability of Z being greater than or equal to 2.35. But I know that when I add that to the probability, right, that 0.9906 to this probability, it must be equal to 1. So I can simply transpose to get this probability. So I'm going to subtract both sides of the equation by 0.9906. And if I do that on the left-hand side, I'll be left with the probability of Z being greater than or equal to 2.35. And on the right-hand side, I will have 1 minus 0.9906. Okay? So the probability of Z to the right of 2.35 is going to be equal to 1 minus 0.9906, which is going to be 0.0094. Okay, that is going to be my answer. Great, but remember, we're not finished yet, right? We're not finished yet, because what we just calculated was this, right? So we just calculated that part, and we also calculated this part, all right? But this probability here at the end, right? This one here, that probability there is the one that I'm trying to find, right? So I'm just going to substitute the values for these two probabilities that I've highlighted in yellow. Okay, so the probability of Z being less than or equal to 0.87 is going to be 0.8078 plus the probability to the right of 2.35 is going to be 0.0094, right? We just calculated that, plus the probability that we want is the probability of 0.87 less than or equal to Z less than or equal to 2.35. And we know that when we add all of those three probabilities, it must be equal to 1, right? Great. So all I'm going to do is just to transpose this equation now to find the probability here, right? So I'm going to subtract the left-hand side by 0.878 and also by 0.0094, okay? And if I do that on the left-hand side, I will have the probability of 0.87 less than or equal to Z less than or equal to 2.35 remaining. And on the right-hand side, I will have 1 minus 0.8078 minus 0.0094. Okay? And therefore, I can find this probability by simply subtracting those numbers. And when I subtract, I will get 0.1828 as my solution. Okay? So that value here is my solution for part 3 of the question. Okay, so part 3 is now completed. So that is the end of this normal distribution question. I really hope that it helped you, right? Because these are questions that are tested in your exams, okay? And if this video has helped you in any way, please ensure to like up the video and subscribe to the channel. All right, and with that being said, I am Mr. Garth Reed, student ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.